Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the stereocenters and sources of stereoisomerism in the molecule. The compound is 2,1-propenyl, 3-methylcyclohexane 1-1. The sources of stereoisomerism are A. The exocyclic double bond CH is equal to CH, CH3, which can be cis or trans, but the question fixes this as trans. B. C2 of the cyclohexanone ring bears the propenyl group and is a stereocenter, chiral center. C. C3 of the cyclohexanone ring bears the methyl group and is also a stereocenter, chiral center. Moving on to the next step. Count stereocenters with the alkene geometry fixed. Since the alkene is fixed as trans, the only remaining stereocenters are C2 and C3 on the ring. With two independent stereocenters, the maximum number of stereoisomers is equal to 2 is equal to 4. Moving on to the next step. Check for meso possibility. C2 has substituents, propenyl, trans, H, ring carbons on each side, C1 is equal to O and C3. C3 has substituents, methyl, H, and ring carbons, C2 and C4. These two centers are not mirror images of each other. They bear different substituents, so no meso compound is possible. All four stereoisomers are distinct, 2R, 3R, 2S, 3S, 2R, 3S, 2S, 3R. And for the final step. Why other options fail? Option A, 2 would require a meso compound reducing the count, which doesn't apply here. Option B, 3 would require one meso form, not applicable. Option D, 8 would require 3 stereocenters, 3 is equal to 8, but with the trans alkene fixed there are only 2 ring stereocenters. If the alkene geometry were also variable, we'd have 3 is equal to 8 total, but the question fixes it as trans, so only 4 remain. Conclusion. With the trans alkene fixed and 2 ring stereocenters, C2 and C3, the total number of stereoisomers is equal to 4. Therefore, the correct answer is C. Therefore, the correct answer is option C.